ए कंट्री वी शुड बी वरीड अबाउट दिस कि इंडिया के करीब ये क्या हो रहा है, क्योंकि आज ये हमारी शिप नहीं है, कल को ये हमारी शिप भी हो सकती है। यहाँ पे आप देख पाएंगे, इससे रिलेटेड आपको आर्टिकल दिख जाएगा कि इजराइल लिंक्ड वेसल, एक वेसल थी, बताया जा रहा है कि इजराइल का जो कार्गो है ये कैरी कर रही थी, प्राइमरली केमिकल्स वगैरह। तो जैसे ही ये वेसल इंडिया के कोस्ट के काफी करीब आई, अचानक से एक ड्रोन इस पर आक्रमण करता है ना। ये ड्रोन का आक्रमण किस टाइप का था, क्या ड्रोन ने मिसाइल लॉन्च किया है या फिर ड्रोन ही सीधा क्रैश कर गया इस वेसल पर, इस पे अभी प्रॉपर क्लैरिटी आई नहीं है। मगर ये पक्का पता है कि इस वेसल को अटैक किया गया। इस वेसल में 20 इंडियंस भी थे, कई इंडियंस हैं, ये किस तरीके से कार्गो शिप में काम करते हैं, उनकी जॉब होती है ये। तो 20 इंडियंस भी थे यहाँ पर, वो लोग बिल्कुल सेफ हैं, किसी की मौत नहीं हुई। मगर ये अपने आप में बहुत ही चिंता की बात है कि इंडिया के कोस्ट के करीब अब ड्रोन अटैक हो रहे हैं वेसल्स पर। इससे देखिए बिजनेस एनवायरनमेंट बहुत खराब होता है। गुजरात के तट से 200 किलोमीटर दूर कुछ इतना दूर नहीं होता। आप अगर ओवरऑल इंटरनेशनल ट्रेड के हिसाब से देखो तो शिप्स इतना डिस्टेंस बहुत ही आराम से कवर करती हैं। तो इंडिया के काफी करीब माना जाएगा ये। इंडिया के इतने करीब अगर ड्रोन्स अटैक कर रहे हैं तो वी शुड बी कंसर्न्ड, और इसलिए इंडियन नेवी एक्टिव हो चुकी है। इंडियन नेवी ने अपनी जो वॉरशिप्स हैं ये भी भेज दी है। और आपके माइंड में एक क्वेश्चन आएगा कि ये सब किसने किया होगा, किसने इस इजरायली लिंक्ड शिप को एक ड्रोन से अटैक किया है ना। यहाँ पे आप ऐसे कई लोग ये कह सकते हैं, अच्छा ये मोस्ट प्रोबेबली यमन के हुती रिबेल्स होंगे ना। आपको पता होगा यमन के हुती रिबेल्स लगातार इजराइल पे आक्रमण करने की कोशिश कर रहे हैं। जो भी शिप्स गुजरती है रेड सी से, जहां पे कुछ एविडेंस मिल जाता है कि वो शिप इजराइल से लिंक हो सकती है, इजराइल की शिप हो सकती है, उसको काफी बार हुती रिबेल्स टारगेट करते हैं। तो मोस्ट प्रोबेबली वही होंगे ना। वेल प्रॉब्लम देखो ये है, अभी के लिए हम कुछ सर्टेनिटी के साथ नहीं कह सकते। यूके की तरफ से आप अगर देखो, जो यूके मैरीटाइम ट्रेड ऑपरेशंस है उनकी तरफ से एक ये रिपोर्ट पब्लिश हुई है। उन्होंने बताया है कि कैटेगोरिकली कहां पर ये वेसल थी, कहां पे अटैक हुआ है, बट किसने ये अटैक किया है, कहां से ये ड्रोन आया था ना, इसको लेकर अभी कुछ प्रॉपर क्लैरिटी है नहीं। और किसी ने क्लेम नहीं किया है कि हम लोगों ने ये स्ट्राइक किया है। मेरे हिसाब से एक रीजन ये भी है कि ये स्ट्राइक इंडिया के बहुत पास हो गया ना, तो जिसने भी अटैक किया है वो थोड़ा सा आप कह लो झिझकेगा क्लेम करने से कि हमने ये अटैक किया है, क्योंकि इंडिया एक बड़ी नेवल पावर है रीजन में। ये लोग चाहेंगे नहीं कि इंडिया जैसा अभी के लिए फॉर द टाइम बिंग, इस केस में जो हम एक स्लीपिंग जाइंट है, सडनली हम जाग जाए और हम यहाँ पे एक्टिव हो जाए। तो अभी तक किसी ने रिस्पॉन्सिबिलिटी क्लेम करी नहीं है। बट मोस्ट प्रोबेबली जो रीसेंट इवेंट्स हुए हैं उनको अगर हम देखें तो मोस्ट प्रोबेबली या तो हुती रिबेल्स होंगे या फिर ये ईरान भी हो सकता है। ईरान पर भी आरोप लगे हैं पिछले कुछ महीनों में कि ये लोग इजराइल की जो शिप्स हैं, इजरायली लिंक्ड जो शिप्स हैं, उनको किसी ना किसी तरीके से टारगेट कर रहे हैं ताकि इजराइल को इकोनॉमिक लॉस हो। और अगर यहाँ पे आपका एक क्वेश्चन ये है कि ऐसा क्यों किया जा रहा है, तो इसका सिंपल आंसर है इजराइल हमास वॉर। देखिए मिडिल ईस्ट में, प्राइमरली आप कह सकते हैं इस्लामिक कंट्रीज में, इजराइल हमास वॉर आज के समय ना एक ह्यूमंगस इशू बन चुका है, क्योंकि 78 डेज हो चुके हैं, ये वॉर थम नहीं रही। और कई रिपोर्ट्स, अगेन देखो ये रिपोर्ट्स प्राइमरली आ रही है फ्रॉम इजिप्ट, फ्रॉम सऊदी अरेबिया, कुछ
Hello.
हद तक कतर। ये लोग क्लेम कर रहे हैं कि जो इस्लामिक कंट्रीज हेल्प करना चाहती हैं।
Hello, yes, sir.
Hello, sir.
Yeah, you can record Subhajit because BG may be in some church.
Okay, sir.
Actually, she get free at 3 o'clock. So you record this call.
Okay,
Did
sir.
you people went through the pipe?
Yes, sir.
Any doubt in pipe?
No, sir.
Understand
Yogesh,
pipe?
I can't go
Yes.
to pipe. I haven't read that assignment. Actually, I was 4 day. I was suffering from cold and fever. Yogesh.
Okay. But go through it.
I'm
It's
sorry for
simple.
that.
Make program.
Yeah,
Okay.
yeah, sure. I will try today, Yogesh. My health is little better today. I will try.
Fine, fine. So see the pipe having some problem. So can anybody tell what is the problem?
Sir, I have faced one problem. When I haven't put any delay, means when there is no sleeping time, that time uh, all the data it is not fully piped. Sometimes half, or sometimes first to
Yeah,
alphabet.
if process should alive, if process is not alive, then nobody will there to send information.
Okay. Okay.
So one problem in a pipe, like can anybody tell what is problem in pipe? Pipe having one limitation. Does anybody know what is limitation?
Sir, both transmission and the reception can it be happened at the same time, sir?
Can happen
Same time. At the same time, it can be send and receive.
that is what we want actually.
You guess?
So we don't want to store it. We
Okay.
want to, if you see my explanation before, so we want to convey one message from one task to other task. That is what our requirement is. The problem with the pipe is it only applicable to the relative task. Relative task only can work it. So what's the meaning of that? Like say you will start and then you need to create a pipe, and after that after that you have to fork it like this. Then this process and this process, like one will be, of course, one will be parent and one will be child, and then they will Subhajit, you are recording, right?
Yes, sir, I'm recording it.
Okay, so parent and child, so like then they both will able to use this pipe. So this pipe is basically, it's kind of connection between these two is like that. So this, the problem with the pipe is, can anybody tell?
You guess?
Mm.
What I guess, similar like race around condition will happen, because if someone will force this information through pipe, whatever output is coming, and again if some other process is trying to push that some information, then
No,
I
no, no.
guess
You go through the pipe first, then you will understand.
okay, okay,
So
okay.
now the problem with the pipe is like it is only applicable to the relative task. Only relative task can use pipe. Task or process, you can say. Only relative process can use the pipe. Like, but if you are having any independent process, like normally we don't have the normally like we may have the independent process, like say currently if you see here, like say so this many processes are running. So consider like say this is two processes are running here, and like maybe four processes are running from here, and one process running from here. So now there is a possibility like they don't have any common pipe established here before forking, is they fork from same parents. So like the parent and the child can communicate, but what about this child and this child, like they want to communicate it, how they can communicate? So this is the limitation, like this pipe is only applicable to the parent child relationship. Only the parent child relationship can have this pipe communication. Understand,
Okay, sir.
Subhajit?
Yes, sir. Okay.
So
Yes, sir.
now, but in actual practical case, we will not have this. We will not get this kind of scenario. We need to have some kind of mechanism where, like, even two independent tasks also should able to communicate it. Like say, so now the thing is like this. This is one task. This is one task. This is one task. Maybe their parents are common. That is possible. But I want some mechanism like this process want to communicate to this process. Like we should have some kind of communication. If we use pipe, then only parent and child will able to communicate it. And that is also before forking, we have to create the pipe. If you see the code which we wrote yesterday, means in last class. So we are creating pipe. We are first creating the pipe, and after that we do fork. So when we do like this, when we create a pipe and make fork, then parent and child will able to use this pipe. So that we are understand this and we able to use it. But what if we not created pipe and we already forked? So in that case, what will happen? In that case, this pipe will not work. There is a 100% possibility like this is one task, this is one process, this is one process, and like they may not have the common pipe. Had you got what I say? Not got?
Yes, Yogesh.
Yes,
So
yes.
in order to solve this problem, we are having something called FIFO. So what is FIFO? FIFO is a named pipe. So FIFO is a named pipe. So FIFO is a named pipe. What's the meaning of that? Whatever pipe we will create, we'll give the name to it. And if any other process want to read or write with that named pipe, they will able to use it. So it is not like it is not like only parent child can access. Anybody who is having the name, they can access the pipe. Yoga got what I say?
Yes, sir.
Okay, so FIFO is first in first out. The pipe also work like this, right? In your home you have pipe that also work like this only. Whoever enter first here, first in, first out. So this is the property of pipe. First in first out file is the pipe that has the name. So any pipe that is having a name is called FIFO. So FIFO file is a pipe that has a name. So you can say the pipe that has a name is called FIFO. So FIFO again same thing we are repeating third time. FIFO is a also called as named pipe. FIFO is a named pipe. FIFO is designed to let them get around and all shortcoming. So in the normal pipe, whatever problem we was having, the main problem was like it was only applicable to the relative processes. So that problem we had removed in the FIFO. How it work, I'll tell you. So consider this is process 1, this is process 2. We create one named pipe, like you can say like this, named pipe. And through this named pipe, anybody able to, one person can write it, one person can read it. We created one named pipe, one process can write it, other process can read it. Is okay
Okay.
till now? Little
Okay,
bit
sir.
understanding.
Okay, sir.
FIFO creation. So how to create FIFO? FIFO can also be created to like how we create the file, same way we can create, but we need to have the special permission that I'll tell you in 2 minutes. And Then like after creating FIFO, we can do the read write, how we do normal read write we do. And finally, we are passing the device number that is ignored when we creating FIFO, that we can put anything, and that like I will explain you like how we can do it. How we can do it. So for that we are having system called MK node. So MK node what it do? MK node what it do? It will give the, we can configure the MK node where the FIFO need to create it. That is the path, like any path you can give. And then with the mode is the permission, like read write permission. And this dev, this can be 0. What's the meaning of this? I'll show you. Like we have to create the, so it's like that. We have to create the node, MK node. So two thing is there. One, like I'll try to show you, but I forget. Let me try it. Okay, so see what I done is here, like I did the main, MK node. So, like those who people newly joined, two of you is newly joined, so I'll tell you. So we, in the last class, we had seen the pipe, and I hope you people went through the pipe. Any doubt in that?
No, sir.
Okay. So, in the pipe there is a problem, and what is that problem is like only relative process can use the pipe. Why? Because uh, before forking, before fork, we have to do the before fork we have to create the pipe, and then we have to fork it. So that was the uh, that's how pipe work. It's like it's for relative process only pipe work. But in practical cases, there may be two process which is like independently running. So like say, like if I see here, main ls. So this main, if when I enter main ls, this will be one process, and if I pipe it, this is how I pipe it to another process. So like the output of this process is going input to this process. These two process are relative process. This will be parent process and this will be child process. So this is how these are the relative process. So if I fire this command, so what happen? This become parent process. It completed task, and after completing whatever output it got, it will give input to the another child process. So that's how like this parent process and child process are able to use the pipe. But if I want to do same thing like main ls, so this will be one process here, and on another terminal I want to grab print, like that. So now what is the thing? This going to be one process, independent process, and this going to be independent process. Two independent process, if they need to communicate, they cannot communicate using pipe. Had you got?
Yes, sir.
Okay. So for that purpose, we are having something called named pipe. It is called FIFO. FIFO is a named pipe, and how it work is like the FIFO is a named pipe, so that you have to remember it. How it work, that I am explaining. So we create one pipe and we give the name to that pipe. So what happen is like whatever data one process will send, other process will receive it. It's something like that. And so how it work? In order to make the FIFO, we have to use the MK node. So MK node is a system call. Then what I did the main of MK node. MK node. So when I enter into MK node, so MK node is a command. MK node is command, and how it work? It we have to give the MK node, then we have to give name. So whatever name we want, we can give, and after that type. After that major and minor number. So that is how we have to use the MK node. What's the meaning of that? So MK node name, you can give any name. After that type what you will be doing, see it mention here. If we have to give the permission, like who is having the read write permission, so we can give using -m. So using -m in the type, like we will give MK node and whatever name we want. Then the type, in the type we will say -m, and then we'll set the permission. And after that we have to tell the one more important point, that is the either we will use the major and minor number. You may not know currently, but currently we want to use that as a creating FIFO. So like we will use the P. So that's how is our full command will be. So let's make one mk node, then I will say the name. So name I will say maybe class fifo. So this will be the name of my fifo, and then I have to give permission. So permission I will give read write permission to everyone, and after that I want to create the task. So I will not execute this command. Before that I will show you, like, I don't have any see, I don't have anything called class here. In this, if you search, you won't get anything called class, because you should not think like I already have it. So now I am creating. So mk node, then the name. So I'll say class fifo, then minus m, that is my permission, and then I want to create pipe. Done. Now if I check ls, you see I am having this class fifo. And if you do the ls hyphen, so this p, when it come p in the beginning, this p is called the pipe. So this is having pipe, and since I given permission for 060606, that's why, like, all three people, user, admin and group, all three are having the read write permission, since I use here 060606. Okay. So now my pipe is created, and if you see here, if you see ls, so you will see somewhere this class FIFO. So my pipe is now created. No, sorry, my FIFO is created. Now, if using this FIFO, if I say cat, and I want to write in this FIFO. I want to write in this FIFO. And on the other process, I want to read it, this FIFO. So now here I am just reading the FIFO, and here I am writing in the FIFO. So let's write it. So I in one process I am writing in the FIFO, and another process I am receiving it. Okay, if I write here, this won't come here, because this is not in the receiving mode. But this is whatever I will write here. If I write anything here, and then I will be receiving here. So this is how the FIFO work. Any doubt in this, you can ask. Then we will do the programming as well.
Okay, sir.
No doubt it is.
No doubt. BG?
No, sir. No doubt, sir.
Yes, sir.
Understand what I am explaining?
Yes, sir.
Okay, so whatever we done till now, like, we will do now with the programming as well. So same thing we can do with the programming also. When I do main mk node, I got this information. This is for the command. But I can do now, if you go in main mk node downside, they will say also see mk node 2. So how to see main to mk node? So this is like my mk node system call. So for that I need to use this many files, and then I have to create mk node like this. And when I create the mk node like this, I have to give the name of my FIFO, and then which mode I want, and then dev. What's a dev? I'll tell you. Then okay, so the system called mk node create the file node, which is like a special file or named pipe. with this path name. So whatever path name I will give, with that it will create the file with the attribute of the mode, like whatever mode I will give that. Mode means like permission, whatever I'll give. What's the meaning of mode? It explain here. The mode argument specify the both file mode to use, the type of node to be created. It should be combination of using bitwise OR. Basically, it's saying like that read write permission or what kind of permission we want to give, that we have to do it. And apart from that also it may have some more thing, but like this mode is saying what is our permission. And the the file type must be one of the this as fifo is a regular file. One second, where we have to give this file type. If the file type of this, then dev is major minor number. Okay, fine. So this I have to do with the mode only in that case. File mode is mask in the something else record has been created. The file type. File type should be part of mode. One second. Sample and path name. Mode argument specify the file mode used. It should be combination of using bitwise or listed below and 0. Okay, fine. So what we have to do is in our case, if we want to create FIFO, that also we have to give in this argument only, mk node, this mode only we have to say the read write permission and means like or this one s underscore FIFO. How to do that I'll tell you in 2 minutes. And then like if it's mentioned here, if the file type is this one, then the third argument, which is dev, will be major and minor number. So this you may not understand what's the meaning of that. See, if the mode is we configured for this two, then we have to use third argument. Otherwise we can ignore it. See, they mention it. If my second argument is something like that, then we have to use third argument. Otherwise we can ignore the third argument. So how to do this? What you understand till now? Anybody understand what I talked? What I was talking?
So you guys, you was trying to create this class FIFO, and using that you was trying to communicate using this class FIFO. You was trying to communicate from one terminal to another. It's, I would say, one process to another process. Using in one terminal you was writing a command, and in the other term in other end you was receiving it.
That I already did it. On terminal, I already did it. Now what I am trying to do?
So you are trying to. So you are trying to do it through that program.
Yes. So now I have to do through the program. Through the command line, I already told. I hope you people seen that. So when I was sending message from one process, the other process was receiving the that message. That we already saw it. Yes.
Yes, sir.
Yes.
So
Yes,
now
sir.
what we are doing is we are trying to write the program. So while writing the program, we have to use the AMK node system call. This AMK node system call first we have to give the file name. So we can give any file name you want. Okay. Then whatever name you want, you give it. But the second argument is mode. So what you will give here mode? This is mentioned here. If you read it, you will understand till here. So what it's trying to say, you give first the read write permission, whatever permission you want, that you give. Apart from that, you have to select any of this 1, 2, 3, 4, 5. Any of this you have to select it. So if you select FIFO, it will create FIFO for you. Then what about this third argument? Like here is third argument is also there. So what about that third argument? That third argument is only work when if you are choosing this kind of file, then only you have to use the third argument. So currently we are not doing the kernel programming, so I'll not talk about these two argument. So till now you understand like how to create the FIFO through program. So you got like how to create the FIFO file, whatever name you want that you created. So using mknode, we can create our file. And once we create the file, once we create our file, then we have to open the file. We have to open our file in one program. We will open for the reading purpose, one file writing purpose, other file reading purpose. So what we will do from the once we have file descriptor, we already know this type of reading writing we already done in our C programming. So now we are having this file descriptor. Using this file descriptor, we will be writing the directly data, write it and then write new data and something like that. And whatever we write it in another process, we will again open file, same file we will open, and instead of writing, we will open for the reading. And in that file, in that program, what we will be doing, we will be instead of write, we will be read it, this file descriptor. And whatever, after reading, whatever we get it, that we will print it. Yoga, what I said?
Yes, sir. In the MK node, we'll be first passing the first one parameter as the FIFO name, and second is the read write permission, and along with that, the R, it will be R with that FIFO s underscore FIFO, and third is not applicable. It is applicable only for the kernel operations, and apart from this, we will be creating write permission, and we will be first sending the FIFO name, and then the data we want to transmit here.
Correct. So whatever we will be writing in this file descriptor, that will be
Yes.
going to that FIFO. And on
Yes.
another
Yeah.
program, we will be again open the file, same file we will open, but not for writing, we'll open for reading.
Yeah. Yeah.
Yes.
Correct, sir. Yes, sir. Yes, sir.
And then instead of writing there, we will be reading it.
Reading operation. Yes, sir.
And then whatever we read, we will print it. So that's how,
Yeah.
like you can say, two uh, non-related process will also able to communicate it. So you can say this program is for the writing purpose. Same way I am having the reading purpose. So what I do, I again try to create the FIFO. If with the same name FIFO is there, it will not create again. It will simply give the pointer. Once I got the FIFO, I'll open it, but for the reading purpose. And then I will simply read and print it. Read and print it. That's all. That is what we are doing it here. And then close it. Anybody having doubt in this?
No, Yogesh.
No, sir.
Sir, why we
Yes,
are
sir.
reading two times there?
It's our wish. Like whatever data we are sending from here, one time also we can do. If we give one time, it will receive one time. If we give two time, we'll receive two time. If we put in a loop, we will receive in a loop. Yes, no, not understand.
Yes, sir.
Yes.
What you
Understood. We are
understand?
reading, writing two times, so we are reading also two times here.
Yeah, yeah, yeah. Yes, yes. That we can have like maybe some kind of communication, like instead of we in the before itself we can say like how many first variable can tell like how many time we will be writing. So first variable say 5. So it means like we are going to write the 5 time, and then once we hit receive 5 here, then it will loop 5 time for the reading purpose. So we can have some that kind of program. But had you got what I say?
No, sir.
Yes.
Shikhar, what I'm trying to say is like say this first I'm sending 100.
Okay.
So I am receiving here 100.
Okay. Okay.
So I can put loop, this 100 means like 100 bytes going to come. So I can put 100 time loop here, and here also I can have 100 time loop here.
Mm, okay, sir.
Like if I send here one, it means like only one time I'm going to send, and then like only one time I'll loop. It's our wish. Like how we write program, that is not a matter. The main matter is like the one process is sending data, another process receiving data. That is the main thing.
Yeah, sir. Understood,
In
sir.
pipe also it happening, but pipe only happen with the parent child process.
Yes, inter process. Only the same related process, relative
Relative
process.
processes. This is happening with the non-relative processes because our pipe having a name.
Okay.
So I know like some of you is not completed C programming. So some of you don't know some of the C operations. That's okay. All the best for that. Do faster if you can. So now I'll give you the example. Like I'll try to write this program. Let me see if I already have that program. Yeah, I have this program. I'll open it. If it is same program, we'll use it. Yeah, if you people want, I can write also again program, or if you want, I can explain same only. Do you want me to write program?
No, sir. Explain.
Explain, explain, sir.
Okay, I'll explain this program. If you have doubt, you can ask me anything. So what I did, I'm creating MK node, and then here is the my FIFO name. I will change the name. So I will say Sunday, Sunday 24. So this is my name of FIFO, Sunday 24. And like this is the permission, like I want to give read write permission, and then I want to create the FIFO. When I'm creating FIFO, this is argument is irrelevant for me. And I'm checking with the -1. Why I'm checking with -1? Because if I go main MK node, what it written? Oh, sorry. I have to do main 2, and what it written? MK node return 0 on success and -1 on error. So I am checking -1. If it is MK node return -1, then I will say error and I will exit it. But if it is not -1, then it will come here, and then I'm just printing some message like my FIFO created like that. Now I'm trying to open the FIFO in write mode. So I'm trying to open in write mode. Then this open system called also I'm checking the whether any error or not. Okay, so like if I'm not able to open, I will say I'm not able to open. Consider I opened it successfully. So now my file is opened. Now I can, what I can do is I can write the data in this file descriptor. On this file descriptor, I can write the data. Data value is here. Whatever we want, we can have that data. 356 I am sending. So like that it will send, and then I'll close the file descriptor and go away. On the other hand, Vim FIFO, and then I will open the read one. So here what I am doing is, like, again if I make it, I can make it, no problem. Again I'll try to make it here FIFO. What name I given? What is the name of
Sunday
FIFO I
24.
given?
And that,
Sunday 24.
Okay. So Sunday 24, yeah. So I'll try to open my FIFO, and if it opens successfully, I'll say like my FIFO created. Now I will open it in the read mode. Now my file, I am able to open it. Now after reading, after reading, what I am doing is, now I simply reading that from that file descriptor, whatever this file descriptor, through that I am reading it, and whatever data I get, I am printing it here. And then I am close the FD. Any doubt in this reading and writing program?
No, sir.
No,
No,
sir.
sir.
BG, had you got what I say?
yes, what we use 365?
Any number you can,
No, sir,
any
I'm
number.
clear.
It is just any number. What is,
Hmm. No, why are we using it?
sorry,
Why we are using it?
why we are?
Using this data 356.
Any, say Jesus birthday, right? So consider 25th December and consider Jesus thousandth birthday. So like this data, any data, okay? It is not like that.
Okay.
Any data we are transferring, we are writing in the FIFO.
Okay.
In the from other process, we will read it through FIFO.
Okay,
It's
sir.
it's something like that. See, from one process we are writing it, and from another process we are reading it, like that.
Yes, sir.
Any data you can say. Not understand?
Yes, sir, understood.
And why we have to communicate between two process? PG?
Why we have to communicate?
Hmm.
Like, oh, like the process need to communicate
Yeah, why?
to if there is some command, uh, not that. No, sir. Why need to communicate?
Anyone? Like why we have to do this process?
So to perform a specific task.
Perform a specific task.
Yeah, I mean any
Any
task.
To share
So
one
while
program's one process data to with another.
sir, while running the system, any thread is happen. So that thread is assigned to another process. So that communication need to be happen in that process, inter process. Actually, the pipe we can use only relative process, but in that we can use PIPO, we can use the inter process between different process. We can communicate with the different process.
Hello.
Yeah, hi. Yogesh.
Hi, sir.
Yeah, yeah. So I was asking like why we need to use FIFO.
Yogesh, to remove the limitation of the this pipe, we use FIFO. Like we can intercommunicate between the independent processes.
BG, had you got what he is saying?
Yes, sir. Two process need to be communicated.
Why
First,
they need to communicate?
oh, it was no that I don't.
Sorry,
Maybe to perform some task.
to perform some task. Like for that, do we need to communicate? Consider you have to add two number. Do you have to communicate anything for that?
No, like both process have to uh, perform some task together. They need to communicate.
Like, can you give some example?
Um, like in computer, uh, many process are that pipe process, gray process. They are like one process is done after based on another one's output.
Hmm.
So in that they need to communicate.
Yeah, can you give some example? I'm not understanding.
Like grape,
Hmm?
pipe.
Okay, so what pipe was doing?
Pipe was doing like it work on the basis of another process output.
One minute. Say again what you said.
Like uh, in pipe, uh, second process is the first process output is second process input.
Hmm. Okay.
Uh, so they are like relational process. Mhm.
Yeah, so they want to actually see, consider when I say addition of two number. So this one process will send the number, other process will do the square. So consider like say I want to do the square of 25. So this one process will write the data of 25, and this process will read the data, and then it will do the square of that data. So now, like one process will write the number and another process will be doing the square of it. Let's see it happen or not. So now one process we will be writing FIFO write, we will be writing here. So now it will be, means it already write it, but this is blocked until unless like another process read FIFO, it won't close it. So now we have to read it here. Okay, so like say, since like I was like file was exist, it is not able to, my read program is not able to create it again, because this my write program is already created the file. So what I have to do here, Vim, fifo read.c. That's why like this was commented, like I am not. There is one more method for this that I'll tell you in few minutes. So I will not again try to create the file. I'll just simply try to open the file. Oh, sorry. See, like here I was like making this file, but here I use open wrong file actually. Because I changed the name, so here also I had to change the name. So I have to open the correct file. I was opening wrong file. But in the my write program also may be mistake. 1 minute. Because Sunday 24, so I have to open the correct file. I am opening the wrong file. Okay, so now I opened the build both file. Now I'll run it. Okay.
अबे नेटवर्क की होला बोलतो बोल दी नेटवर्क की होला बोलतो कोट ना कि ना एलेक्सा एलेक्सा स्पीक ऑन
'E' exist. Okay, so what I will do is I will check here, like if my this mk node is returning -1 and and uh, 1 minute, I have to check error actually. So where it will update the error. return value m cannot return 0 on success or -1 on error which in case error number is set appropriately. Okay, error number, fine. See, in case of failure, what will happen? It will return the error number is a one variable that will be set appropriately. So I have to check the error number. Error number is not equal to so I will give this error if only if I got failed and my error is not equal to exist.
Okay.
Do people got what I say or not understand?
Sir, the exist is error name.
A file is already exist. The name which we are taking, that is already exist. Because we already created na one time. This is second time we are running. In the right time also we created that. See, now I'm not getting that error. I'll show you what I did. See, if I not write this, what is happening is like I am getting I am saying MK note failed. I'm getting MK note failed. Why I'm getting MK note failed? Because my Sunday 24 file is already there. If I consider, say, if I run this, I'm getting error, okay? But if I delete this file, so I'll say, see, now I don't have Sunday. And now if I run this, my program, it won't fail. It will see it process further. But if I now in the reading time also I have to open same FIFO. So when I'm trying to open in this program, if I not write this, what is happening? Like it will say, oh, file already exists. I will not open it and it will say failed. But how to solve this problem? I did like this. What is this? If I go in a manual page, main to MK node, you see what it says. If path name is already exist or symbolic link, this call will fail and return fail with EE exist. EE exist means file is already exist. Then I went to here, the return value. The MK node return 0 on success, -1 on failure, in which case the error number, this is a variable, error number will set appropriately. Error number set appropriately. Then it means what I have to do, if my error number is EE exist, it means it is not a problem. It is like file is already exist. But apart from that, if any other error is coming, it means like that is actual my problem. Are you people getting or not getting? Let me know quickly.
Yes, sir. Yes, getting.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So see what I did just now. Just now I again again, like you see file is here. If I again run this write, it will say file exists because I not did changes in the write. Did changes only in the read. Only in the read file I changed. Okay, no problem. So what I'll do is either I can correct that write file also, or I can do the remove this Sunday, and then I'll run it one time right here. Now it opened the file, and it's even writing also. Now I need a read program. So I'll say close. I'll say gcc fifo r.c mso fifo r, and then I'll run it fifo r. See, we got, so from one program we send what we send BG from here
25.
25, and what we are printing here.
25 square.
Yes, so that's how two program is communicating. They are independent program.
Okay, sir.
Any doubt in this, you let me know.
No, yes.
No, sir.
Clear?
No, sir.
Yes, sir.
Okay,
Yes, sir.
so it's this call is already recorded, so you can watch again and do the practice. And in next session we will see the shared memory. So this is like a FIFO. Then we will see the shared memory. That is the next section of IPC, interprocess communication. Okay, that's all. Bye bye. See you.
Okay. Thank
Thank you,
you.
Okay,
sir.
sir.
Yeah, bye.